Okay, guys, so this is week 4. Week 4 is over the coordinate system and intro to linear equations. Ignore all that stuff. But this is what we care about. We care about. Ugh, God, that's ugly. We care about coordinate system and intro to linear equations. And so, without further ado, let's go ahead and start. So, you guys are familiar with the graph. Wait, I want. Okay, you guys are familiar with the coordinate plane. Okay, so this here is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. And if you notice, we always start here. We go counterclockwise. Counterclockwise. Okay. So you always want to start there, and then you want to work your way around the opposite way a clock would go. This is your x-axis. This is your y-axis. And this here, 0, 0, is the origin. Okay. So let's go ahead and add some more. What else? Horizontal is left and right. Okay, you can think of like the horizon. And then vertical is up and down. Okay, it's up and down. That's vertical. So the y-axis is vertical and the x-axis is horizontal. Okay, and so next page. Oh, I just went over that. Here's a nicer picture, neater, if you want to look at it. These are just Roman numerals. 1, 2, 3, 4. Origin, y-axis, x-axis. And, yeah, that's pretty much it. I really went over all of that just now. Oh, this is one thing you should know. Here, a point here will always be positive, positive. You know what? It's hideous. Positive, positive. A point here will always be negative, positive. A point here will always be negative, negative. And a point here will always be positive, negative. So quadrant 1 is always positive. Quadrant 2 is negative, comma, positive. Quadrant 3 is always negative. And then quadrant 4 is positive, comma, negative. Always, always, always. So, like, if they're whatever point, like, the x is going to be positive and then the y is going to be negative. And then here, the x and the y in this quadrant are always negative. And it just kind of, just a rule of thumb. Okay? So, let me see if I might be able to go back to those. Okay. So, what's it mean to be independent? And then what does it mean to be dependent? Independent, it just means nothing affects it. Okay, if you're an independent woman, then you're not going to let anybody affect your self-esteem, you know, because the self-esteem, you don't rely on other people. You really don't rely on anybody. Nothing affects you if you're an independent woman, right? If you're independent, then, like, financially speaking, you're not affected if you have your own, like, if you have your own source of income, like, you got it. Emotionally, like self-love or like anything like that. Independence means that you don't rely on your friend to compliment you. You know, you don't rely on your boyfriend to compliment you. You compliment yourself. You show that love to yourself. All right, so it's the same definition, like how we use in real life. It's the same definition in math. And then with to be dependent, that's obviously the opposite, right? So, like, children are dependent on their mother and father or their caregiver. It just always matters what else is going on around them. You know, if a child is hungry, it depends, you know, are they with an adult? If they're with an adult, chances are they're going to get fed. If not, you know, they may stay hungry. Okay, so independence or dependence are the same definitions in real life and in math. And so in the math universe, the x value is always the independent variable. Sorry, I'm so sloppy in writing. In the math universe, y is always the dependent variable. Okay, so y always depends on x. Okay, kind of like an annoying boyfriend or girlfriend. So y always depends on x, right? Whatever x does, y is going to copy. Not copy, it's going to matter to y. Okay, so here's just some definitions for you guys. Make sure you know them. Make sure you have them written down. So, we just talked about this. Domain, range. Oh, no, we didn't. Well, we talked about the red. Okay, so the domain, and we're going to talk about this more as the video goes on. Domain is all of the x values. Okay, so make sure you have these written down. And then range is all of the y values, which again are independent, dependent. A coordinate point, you guys know them as ordered pairs. I call them coordinate points. So literally, like, here, 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 here. That's just a coordinate point. That's just a point. Okay? And then a function, guys, it's really just a relationship between a dependent variable and the independent variable. Okay, so functions describe how x and y are related, how x and y are connected. Okay, functions, very important. Functions describe how x and y are connected. Okay, so moving on. So about linear functions, you should always write this down. You should write this down also. So they're straight like a line, so it's really easy to tell if a function is linear, right? They always have a y-intercept, and they always have a slope, which we're going to talk about those. They can be increasing, decreasing, or constant. So an example of an increasing linear function would be like that. An example, so that's increase. An example of a decreasing function decrease. And then an example of a constant function. This one's kind of weird. It's flat, okay? There's, it's literally just a horizontal line. Okay, so, oops. So this is all, imagine like a guy walking and he's going up a hill, right? He's going uphill, right? So that's one way to think about it, like just like looking at a graph, you can tell like if something is going like uphill or downhill. All right, so same hill. So this guy is on the hill. He's going down, right? So just put a little person on the graph. Okay, so that's really like the best way that I can describe increasing and decreasing. Usually if like, okay, a function, let me start a blank page. So obviously a line like this, a flat horizontal line, this is neither decreasing nor increasing. Neither increasing nor decreasing, I'm sorry. Okay. Because it's just staying exactly the same. It's not like going up, it's not going down, it's constant. Okay, constant, it's not changing. Not changing. So a lot of these words that we use in the math universe, you use them in real life. The definitions are the same. Okay, so now let's talk about like, say this is your, God. Okay, say this is your plane, your coordinate plane, and this is your x-axis, and this is your y-axis. So, and this is like your 0, 0 right there. Okay. So say if I have a graph and it's like this, right? Oh my God. Literally. Okay. Say I don't know what is that increasing or is that decreasing. So one way I can determine if it's increasing or decreasing, I can look at how the right, because there's like a right end and then there's a left end. So I need to look at how the right end is behaving. So is the right end, is it above the x or is it below the x? If it's above the x, then it's increasing. If it's below the x, or if it's like headed like towards like below the x, then it'll be decreasing. So another example would be like, okay, let's look at the right side. What's it doing? Is it heading towards that way, or is it like, do you think it's going upwards? In my opinion, it's definitely headed towards like that, right? So you really just kind of have to like extend the left and the right hand ends, and then you kind of have to, maybe like the hill works for some people. I know it doesn't work for some people. So he's going uphill, he's going downhill. So it just takes a little practice. Okay, so next. Okay, this is very important. This is called the parent function for linear equations. I think it's important to just know this now, and then I'll go back to this. So just make sure that you copy this down exactly how you see it. Notice that, okay guys, notice that at every little point, okay, so that's 1, 1. That's 2, 2. That's 3, 3. And then that's 4, 4. Same thing. -1, -1. This point is -2, -2. This is -3, -3, -4. So in this case, I mean, it's obvious that the y and the x are equal to each other. Look, x and y are equal. This is the x, this is the y, and they're equal. They're the same number. X and y, same number, they're equal. X, so, I mean, I'm sure you guys see it. So when x, it's all it's saying is that x and y are always going to be identical. And this is called a parent function. Okay. This is an increasing function. Okay. It is headed towards, it's going like uphill, right? It's going that way. It's going up the hill. So you always want to look at the right hand side of the line. Look at what the end point, or what the end is doing, how it's behaving. Okay. Very important. Make sure you get that. Oh my god. This is also very important. Just take a moment to write this. The blue, the slope, is known as rise over run. So we're going to talk about this formula. And then in the red, we have the y-intercept, which is just a coordinate point. It's just a coordinate point, and that's known as, you know what, that's known as B. All right. And that's really it. So these are the two parts of a linear function. So your first part is your slope. Your second part is your y-intercept. So your y-intercept can be positive or negative. Can be positive or negative. It can be 0. And yeah. It can be a fraction, but we're not going to see that many of those. At least I don't want to see them. The slopes are almost always fractions. You always see them as a fraction. So we're going to go over that very briefly. Next page. Okay, so let's talk about the y-intercept. The y-intercept, literally the word interception, it means, I mean, I wish I knew enough football, but if you're a football fan or you play football, you know what interception means. It means some guy with a ball. The ball. Okay, that's an ugly ball. Some guy with a ball, right? It's the red ball. Try and draw a football. He has a football. Okay, and then another guy from opposite team. He wants to get the football. So he's going to run. He's going to go this way. So they're going to cross eventually, right? Because this guy's trying to run that way. And the blue guy, the opposite team guy, he doesn't want this guy because this is the goal. Right? This is where they score. So he needs to intercept this guy. Right? He needs to intercept this guy. And so what happens here is they end a cross. Okay? They cross here. Very important. And so y-intercept, it's literally just the definition of y-intercept is where the graph meets the y-axis. Okay? That's literally what the y-intercept is. It's just where the coordinate point, it's a coordinate point. Oh my gosh. It's a coordinate point where the graph meets the y-intercept. So it's literally, it's where they like intersect. Or they intersect. Or that. Intercept each other. So like, say that's your coordinate plane. And this is your graph. So whatever this point is, it's your y-axis,
No, we don't, Mom.
x-axis. Then you're just gonna have to literally just like find out whatever point this is, and then that's your y-intercept. So it's literally just whatever this point is. Let me see if we're gonna talk about slope. Oh, there it is. Okay. Okay, so here's just some visuals for y-intercept. They're better than what I drew. So let's zoom in on each one. So that's literally just the y-intercept. Literally just the y-intercept. So all you gotta do is... sorry guys. All you gotta do is just figure out... It label. Obviously it's a coordinate plane. It labels everything for you. So that is just 0, 1. So that would be your y-intercept there. And... same thing. So like here, let's talk about this image. That is 0, 4. Okay, that's your y-intercept. Very, very easy. Really easy to find them too. You just literally, you look for where they cross. And so here that would be 0, -2 would be the y-intercept right there. Okay. This is known as the x-intercept. It's the same concept, it's just the x-intercept, but it's not something you super need to know. Okay, so now let's talk about rise over run or slope. So this formula in the pink box is super important. So make sure you write that down. Sorry, you gotta check something. And so we're gonna do some examples. Okay. So, say I have 2 points, right? We're going to do lots of examples. Say I have given 2 points, let me see, find the slope. Two, 5, 9, 12. Okay, so very quickly, this is obviously the x. X is always first, and then y is always second. So we have 2 x coordinates and 2 y coordinates. So since this is just the first point, I'm just going to call this x1 and y1. And since this is the second point that they gave me, I'm just going to call that x2, y2. And so now I have everything labeled. Okay, so the thing that I feel like trips people up is the ones are always going to stay together. So the 1s and the 2s are always going to stay together. Okay, it's not going to be x1, y2. It's not going to be x1, y2, or it's not going to be x2, y1. It's always x1, y1, x2, y2. So now we have everything labeled. I don't like the highlighter. We're just going to plug them into the equation. So number 1, label. Number 2. Stop it. Oh. Number 2, label. And then number 2 is plug in formula. Then number 3, do the work. Do the math. And then you actually like start on the problem. So like steps 1 and 2, you're setting yourself up, right? So like if you copy the problem down wrong, or if you copy like even one tiny thing wrong, you're like you have to start completely over. So using the right formula, using the right labels, knowing what each part is, just in general, and then starting on actually like the math, like setting out everything you've been given, everything you know. That's one of the most important parts in actually solving any math problem, is like the I want to say pre-game, but like, it's not pre-game. But you guys know what I'm saying. Like, so now we're just going to start working. We're going to use this formula. That formula in the pink. So this is what's going to happen. So it says the formula, and I'm going to write in red. It says the formula is y2 minus y1 over x2 minus x1. So what is that? So y2, we're going to just plug in the numbers. y2 is 12. Then it tells me to minus. y1 is 5 over x2 is 9 minus, because of the formula, x1 is 2. Okay, so now what I'm going to do is I'm just going to subtract the top and the bottom. So 12 minus 5 is 7. Up. And then 9 minus 2 is 7. Okay. Now, if I can reduce, then reduce. If you can divide, and if one like goes into the other, like if the top or if the bottom number goes into the top, do that. But if you can reduce, then do that. So this can reduce, actually. 7 divided by 7, which is just 1. So that's your answer. Okay, we're going to do another one. Make sure you're writing this down. Oopsie. Okay, so say I have another example. Say I have 2 points, 1, 8, and -4, 10. Okay. And so I'm going to rewrite the formula. Always, you got to know what formula you're going to use, right? We're just writing the formula. First thing we're going to do is we're going to label, right? Remember, our first step is to label and then plug into formula. And then you start to solve. All right, so we're going to label now. Like always, first things, X is always the first one. And then Y is always the second one. Okay? So now, since this is my first point, I'm going to make that X1. And then I'm going to make that Y1. Since this is my second point, I'm going to make this X2 and this Y2. Alright, every coordinate point has one X and one Y, and X is always first, and there we go. So now we've finished the labeling. Now we're going to plug all the values that we have into the formula. Y2 is 10 minus Y1 is 8 over, don't solve it yet, X2, which is -4 minus 1. Okay, so now we're going to do the top, which is 2. -4 minus 1 is -5. I cannot reduce that. That is an ugly fraction. I can't reduce it. 2 doesn't go into 5, and 5 doesn't go into 2. Like, it's done. Your answer is 2 over -5. Okay. We're going to do another one. More negatives now. -3 and then 6. With -5, -11. Okay. Okay, more negatives now. It's pretty ugly looking, but it's still exactly the same process. First step is we label. We label. That's my X, and that's my X. That's a Y. And that's a Y. Let me actually undo that and make it. There we go. And now, remember, this is our first point. That's just going to be X1. And that's just going to be Y1. Oopsie. X2, Y2. Alright, so we've labeled, and now we're going to plug everything into the formula. Y2 is -11 minus Y1, which is 6, over X2, which is -5, minus, that's that minus. Okay, careful now, it's going to get tricky. X1 is -3. Okay. Alright, so let's do this. Let's do the top first. So -11 minus 6 is -17 over. You guys remember what happens when two negatives are next to each other? They both become positive. So this is actually -5 plus 3, which is -2. Okay, and so when you have negative on the top and the bottom, if you guys don't already know, you can just, becomes a positive. Positive 17 over 2. Okay, and so, no, let's see here. Actually, I think we're good. I'm trying to think. I went over all the parts. So just one more time. Let me start a new page. Oops. Okay, so one more time. Quadrant 1, quadrant 2, quadrant 3, quadrant 4, x-axis, y, let me do different colors. X-axis in green, horizontal, right? Y-axis in red, the y-axis. This is the origin. Alright. I went over y-intercept, x-intercept, horizontal, vertical, quadrants, x-coordinate, y-coordinate, points. Pretty sure that's it. And then, the homeworks, you might have to just, like, plot some points. Or tell me what quadrant they're in. Let me just make sure that I'm not skipping anything, but I'm like 90% sure I'm good to go. Okay, so, yeah, I think you guys are good. So please just email me if you guys have any questions. This is my email. Actually, this is going on YouTube, so I won't do that. So just email me if you have any questions, and if you still have more questions, please just show up to the live meeting. Okay, guys? And I will see you next week. Bye-bye.